Section 4.5 is called linearization, and really it's just talking about how do we estimate using tangent lines instead of the actual function. So why would we want to do that? Well, basically it's just easier to think through a line rather than a curve. We've been using lines since 8th grade, probably before 8th grade, and it's just easier to use them compared to all the other different types of functions that we might be looking at. To give you kind of an idea of where we're going with this, if we just graphed any sort of function and I said I know what the value is right here, that's going to be no problem for me to find that y value. But if I were to go just a little bit to the right and I wanted to estimate this y value, sometimes that can be a little bit more challenging. And so we're going to use the idea of a tangent line through this point, and you can see how the tangent line value would be really close to the estimated value right there. That's kind of the goal of what we're looking at in this lesson. So just to get us started, let's think about the square root of x. If I were to plug a 4 in, I know that I get 2. But what about 4.1? What happens when I plug 4.1 in? I can't do that unless I have a calculator handy. So if I don't have a calculator, is there a way just to get a quick idea of what the answer might be? So first of all, let's find the equation of a tangent line based on 4. And so your book would call this L of x for this section, the linearization. And so to do that, we need to figure out what the derivative is. So f prime of x would equal 1/2 times x to the negative 1/2. And that would really, if we simplify it, it's going to be 1 over 2 times the square root of x. And so we want to know what's going to happen at 4. What's the derivative at 4? And so if I plug that in, I get 1 divided by 2 times the square root of 4, which in the end just gets me the answer of 1/4. Okay, remember for a tangent line we need to know, so that's kind of gross, but of course it's not going to erase for me. There we go. Okay, 1/4. So for a tangent line we need to know the slope. We also need to know a point, and the point they tell us right up here. So I just go ahead and write my answer now, and I would get y equals the slope 1/2 times x minus, okay, the x value is 4, and then plus 2. Okay, so that is my tangent line based on, or what's going on at x equals 4. So what we just did was we said let's look at the square root function, and at 4 let's make a tangent line. And what we're going to do in part B is say, well, what's going to happen if I went just a little bit to the right and I look at 4.1? Okay, well, we can see that the y values from the actual function and our tangent line are going to be really, really close, and so close that we can just use the tangent line formula to get our estimation. So now if I go back up to this right up here, if I plug a 4.1 in, it's going to tell me the y value of this line at 4.1. It's going to be really close to the y value that I'm looking for. So that's kind of our goal here in part B. Use your tangent line to approximate f of 4.1, to approximate the square root of 4.1, just not an exact value. So we go y equals 1/2 times, then we put in a 4.1 minus a 4 plus a 2. And if I go through and I think about this, I'm going to get, I thought something looked funny there. Okay, way up here, you guys should have told me to stop my video here, because this should be a 1/4, right? That's what my derivative is. Okay, so right here, this should be a 1/4. Okay, and as we go through and we simplify now, I'm going to get 1/4 times a 10th plus 2. And if we were to think through that just a little bit, I'm going to get 2.025. Okay, so that kind of makes sense. If we go back to our picture here, if this y value right there is 2, it should be a little bit higher. Now, what's going to happen is this is our estimated y value. It's going to be a little bit bigger than the actual value, and the reason we know that is because of the concavity here. It's concave down. It's going to keep curving down. That means our tangent line will always be above, and so we're using the tangent line to get an approximation. So this will be just a little bit bigger in this case. Other cases, when the function would be concave down, then our tangent line would actually be an underestimate. We'll talk more about that in class. So to finish off, if you have a calculator handy, you can go ahead and find the actual value of the square root of 4.1. If we were to actually plug that in, f of 4.1, just really do this on your calculator, you would get 2.024845673 if you care. But the point is, this is just a little bit smaller than our estimated value, and that's what we kind of show on our picture as well. So jot down any questions, and we will see you tomorrow.